Hello. Ternary ionic compounds. All right. So I'm about to explain what polyatomics are, and I'm going to move the notes out of the way and do this on a different page. You're not responsible for anything until I get back to this. So in other words, you're not responsible for being able to reproduce what I'm about to show you until I get back to this page. All right?
It's ironic that we're learning what a polyatomic is the day before our polyatomic.
Right. Irony. It's super ironic sometimes. All right. So we have carbon here. And carbon, you can represent a carbon-carbon bond like this. Okay, so just a line. This means that there's one electron here, and we connect it with one line, meaning that they're sharing those two electrons. It's called a covalent bond. You haven't learned about it yet, or maybe you have because you read ahead, but it's not important yet. We're getting to that. So let's say that you have carbon and nitrogen together. Carbon has 4 valence electrons, and nitrogen has 5. Yes? And I mentioned last unit that you can tell how many covalent bonds they can form, how many electrons they can share by looking at the singles. They can only share their singles. And so these guys can share these two, maybe these two, and form 3 bonds. And so if I clean this up, it looks like this. And nitrogen has those 2 electrons, and carbon still has this extra one over there. And they all feel like they're full almost. So look, while I count, here's 1, 2, and then nitrogen feels like it's got 3, 4, 5, 6, 7, 8. So nitrogen feels full, but carbon doesn't because it's got 1, 2, 3, 4, 5, 6, 7. And so it needs one more. So this can't happen because, excuse me, because not everybody's full and neutral. Well, if they happen to get around a metal, like say maybe sodium, sodium has 1 valence electron that it wants to get rid of. And so sodium can do this. And now everybody's full and neutral. But what happens when you donate an electron to anything? It becomes charged. So this whole thing now has a -1 charge. This whole thing now has a +1 charge. And so together, they form a compound, sodium cyanide. This part right here, that is the polyatomic. Polyatomic means, a polyatomic ion means a bonded structure of many atoms, polyatomic, and it's charged ion. So polyatomic ion.
A lot of things have to happen for that.
Yeah, so that is very true. So you have to have a metal together with a bonded compound of nonmetals. Thank you, dear. All right. So questions over that?
How can it be a compound if sodium is just giving an electron? Because if it gives the electron, then how is it bonded?
That's how ionic bonds form. So ionic bonds form, you have sodium, it has 1. You have chlorine, it has 7. So sodium's like, here, you can have mine, and I'll be full, and chlorine will be full too. But now they're charged, so they stick together like magnets.
Okay, so they're just, okay,
Yes?
yeah, because they're not sharing electrons.
No, and one donates to another, and that results in both of them being oppositely charged, so now they're stuck together like magnets.
I imagine two planets trying to transfer a single person over, but they get too close and now they're fused.
I'm super happy that that makes things clear for you. Okay, any questions on this? Any questions on why that highlighted area is called a polyatomic ion? All right, so let's go back and add some of this to your notes. Again, you're never responsible for having to reproduce all that. I'm never going to ask you to well, not never. In this unit, I will not ask you to reproduce all that. I will ask you about this stuff that's on these notes. All right, so again, we have sodium with a +1, and we have cyanide with a -1. And so together they make sodium cyanide. This is the polyatomic ion. This is now the ternary ion, ionic compound. Yes? All right. Yeah.
I understand the root word like tertiary.
Uh-huh.
Ternary.
Okay, don't worry about that so much as this. Binary, and I'm going to scooch this out of the way so I can show you, and then I'm going to go back. This is binary. This is binary. These are all binary, yes? 2 elements coming together to make an ionic compound. Ternary is 3 or more.
Oh, okay.
So that's how I remember it.
So I guess it's just ter. That's the root word for ter.
I don't know if the root actually applies on this one. I really don't know where it came from.
Well, then it would be very coincidental that tertiary and ternary both start with T.
I don't know if tertiary and ternary are different words, is what I mean. I don't know if they are different pronunciations of the same thing. I don't know the answer to that.
If the second term is called the polyatomic, is the first term called?
That's just the metal.
I think you accidentally blew my mind.
Sorry? Yes. All right, so a ternary ionic compound by default will have at least 1 polyatomic. By default. Because it has to have more than 2 different kinds of elements. Yeah.
Cyanide is CN4 -1. Where's
CN -1. There's no 4.
I believe you. I want to make sure my 5 cards are correct.
Magnesium cyanide is the first example. All right. Magnesium forms a +2. Cyanide forms a -1. So you know from previous examples that must mean that I need 2 cyanides, yes? Put your phone away. So magnesium. Now, don't write this yet because I'm going to write it wrong. That's not the answer. Why?
Because it's just doubling the nitrogen.
Very good. This says I've got 1 magnesium, 1 carbon, and 2 nitrogens. That's not the same thing as 2 cyanides. So if you need more than 1 polyatomic, you must trap it in parentheses and put the subscript on the outside. So let's jot that down. polyatomic requires parentheses. Sad day.
You can watch
All right. So iron 2 phosphate is next. Iron 2, Fe plus 2. Yes? Because that's what that 2 means, right? Phosphate is PO4 with a negative 3. So you learned from the other day that means I need 3 of these and 2 of these. Everybody okay with that? So my neutral chemical formula is going to be Fe3, and then in parentheses PO4, 2. Now, I'm going to show you what the top wrong answer is. I'm going to put it in red so I can erase it. Fe3PO2. That's the top wrong answer. What did they do wrong? Besides everything. They took this PO4 and they're like, oh, that 4 now needs to be a, oh, excuse me. Yes. Yes, sorry. I had a brain melt. So I need 2 of these phosphates, and so that 4 must now be a 2. And that's not what phosphate is. Phosphate is a P and an O and a 4 together. And the whole thing shares a negative 3 charge. So on these polyatomics, don't mess with the subscripts that come with the polyatomic. They can't change ever. And so if phosphate is PO4, it has to stay P and O and 4. And if you need a subscript, you add it to it, not replace it. Yes? Do you see?
If you mess with something like chloride, it would become a chlorate or hypo.
Exactly. So you change that subscript and you either change it into something that doesn't exist or you change it into something wrong. Yeah.
Do we get the periodic table?
Yes.
Not for tomorrow.
Thank you.
No, but for doing this.
Yes.
Okay.
On Friday. Yes.
I have a stupid question. Why do we have to memorize them?
If you get them on the back of the periodic table. I think it'll become more obvious when I get to the last examples. So humor me until then.
So we can do chemistry in our head.
Iron 3 phosphate. Did you have a question? What's up?
Oh, wait, no. I got it.
You sure? Okay. Iron 3 phosphate. Iron is a +3 in this example. Phosphate is still PO4 with a negative 3. So what? If you want to just wait until the end, I can give you the notes so you can just absorb now. So what's my answer going to be? Do you see it? Oh, I thought you said Fe3 PO4. Oh, I'm sorry. Yes, you were right. Fe PO4. No parentheses because you don't need more than one.
Is this a new example from iron 2? Yeah. Yeah, that's why I'm confused.
All right, you good? The P and the O and the 4 come with the word phosphate. So when you memorized phosphate, you have memorized it as P and O and 4. So it stays PO4. It's kind of like saying, I've got 3 cats, and so I have to put the 3 outside the word cats. I can't change any of the letters. I can't change C, A, or T because that changes what the word is. So I can't change P or O or 4 because that changes what phosphate is. That make sense?
I'll send you on 3 cabs and,
Is there a reason why it's 4?
Why is phosphate 4 oxygens? Is that what your question is? Just because it's got 4 oxygens. That's the way it comes together. If you're curious, which, I mean, maybe you are, I don't know. But phosphate looks like this. You have phosphorus, and it's got 4 oxygens attached, and this whole thing has a -3 charge. So if you change the subscript, all of a sudden you're saying, I don't want phosphate anymore, I want that. And that doesn't exist. All right. Ammonium sulfate is next.
How good does the spelling have to be on it?
Perfect. It needs to be perfect. No. Before I forget to tell you, on Friday's quiz, please make sure that your endings are correct because that's where most of the points are lost. If I forget to tell you, most of the points are lost at the end of the word because you're supposed to change the binaries to "ide," but the ternaries aren't changed at all. They're either "ite," "ide," or "ate," depending on the polyatomic you're using. And so students get on a roll and they name everything "ide" or they name everything "ate." It's the ending that tells you. Yeah.
If we are like
I think we have
the
this.
binary, yeah, like the thing that we did yesterday, how do we know if it's ide or ide? It's like nice.
All binaries are "ides."
Oh, so that's wrong.
All binaries are "ides." It's only the ternaries that are going to have "ites" and "ates."
Why? What are you talking about changing it?
Let me show you.
I mean, no, I understand like the I and 8 thing, but like why?
So this is magnesium bromide. Yes? You get into a rhythm on these quizzes, and all of a sudden you call this bromite.
Why?
Because you're used to working with sulfite, maybe. You just had sulfite on the previous question. Do you see what I'm saying?
She's not saying you're supposed to. She's saying you might do that if you're not careful.
Yeah.
So all the
Like
ones
you said
that
something about changing it.
Yeah, you change the binaries. All binary endings are "ide." So this is a binary compound. So all of the binaries are "ides."
How do you know it's binary?
Let's talk about that toward the end.
Wait, what's the true name of cyanide then?
Cyanide.
Oh, that's.
All right, ammonium sulfate. Ammonium sulfate, NH4 with a +1 charge. Sulfate is SO4 with a -2 charge. Are you okay with both of those? All right, and so you know that that means I need to double up my ammoniums. So when that happens, you end up with NH4, but it's got to be doubled up. Parentheses 2. And then sulfate is SO4, just plain. Please be careful on Friday's quiz to not do that. Don't leave a space between them. They need to be written together.
Because that's how you show the bond.
That's how you show they're bonded, exactly. You good? Questions on this one? MgOH2. So I give you the chemical formula, now I want the name.
Is that why we have to memorize it?
So this is magnesium. And since magnesium's not a transition metal, you don't have to do anything weird to it. You don't have to split it apart. You don't have to look up its oxidation number. You don't have to do anything. It's just magnesium, and then OH is one that you memorized, and it's hydroxide.
Oh, hi.
What is the oxygen in front of the hydrogen if it starts with hydro?
That's a good question, and I don't know the answer to it, but it's one of the oldest polyatomics known, and so they probably named it without really knowing what it was.
So do we have to write OH or can we write it?
You must write OH. You must write OH. Hydroxide is OH.
I think I'm having a stroke. How do you spell parentheses? Okay, I added an extra E at the end. You just looked all wrong.
Oh, it is all wrong. All right.
Wait, I have a question.
Yes, dear?
Why is there a 2 after the parentheses?
That is the correct ratio for magnesium and hydroxide when they're come together, because magnesium's a +2, hydroxide's a -1.
So, okay.
Next is CuOH. Cu is copper, number 29, and it is a transition metal, so that's when it's a transition metal, that's when you have to do the extra step and split them apart. So copper, nope. Cu is a question mark, you don't know what it is, but you do know that OH is OH -1. You do. So that must mean that copper is a +1. So this is copper 1 hydroxide. And I just illustrated why you need to get these memorized. Do you see how without memorizing that these are polyatomics, unless they're in parentheses, it's hard to know what you're looking at? So in other words, without knowing your polyatomics, you're stuck on this. You're like, I don't know, this is copper oxygen hydride. I don't know. Once you have them memorized, you recognize, no, this is a ternary compound. That's a polyatomic called hydroxide. So that's why you get them memorized.
Oh, so that whole thing, CuOH, is the ternary compound?
Yes,
And then just the OH part is the polyatomic?
yes. Yes. Okay, good talk.
Just to clarify, when you balance it out, like it's just to like you match them up.
You're trying to make a neutral compound. Yes.
So you're trying to cancel out the charges?
Yes. Yes.
Can you tell the difference, like when you're looking at like a formula, if it's a binary?
I'm gonna answer that. I will answer that. Let's do this last example and then I'm gonna answer that question. See if you can get this one.
Oh.
See if you can get this one. See if can be gotten by you. This one.
Now say it in Piglet.
All right, so this is 10. So it's a transition metal, which means you're going to have to split it apart and figure out its oxidation number because you don't know it. SO4 is a -2, but there are 2 of them. So that must mean that your 10 is a +4. Yes? Everybody okay with that?
I win.
And so this is 10,4 sulfate. You okay with that? Okay, so how do you know binary versus ternary?
Good question.
No. I mean, it can be if you wish, but. What do these have in common besides MG?
Binary.
There's only 2 different elements to each of these.
Because binary two.
Binary means 2. These are binary, they got to end in "ide." As opposed to, let's not go completely off the rails here, folks. Come on. As opposed to this, shh, or how do you know that this is ternary? It has 3 or more different elements. So when it has 3 or more different elements, you know that there has to be a polyatomic somewhere. And that's where the memorization comes in. You've memorized hydroxide, so you recognize that's a polyatomic. You memorized sulfate, Maggie, and so you recognize that that's your polyatomic. The hard ones tend to be this ones that start with ammonium, because it doesn't start with a metal, and so it kind of throws you. So that's, ammonium is really valuable to get memorized because you know it's ternary, but without having it memorized, you're going to be searching forever because ammonium is the only positive one. Yeah. Ide, ate, or ite. Ternaries end in ide, ate, or ite. But you don't change the ending. It comes already changed for you.
Oh, lucky us.
So this right here is hydroxide. You don't change the ending. It's already changed for you. This is sulfate. It's changed for you. This is ammonium. It doesn't have an ending change because it's acting like a metal.
And cyanide.
And cyanide.
So for the binary ones, what do you mean change the ending?
So this is bromide, not bromine.
Oh,
This is nitride, not nitrogen.
oh, okay.
Nothing new. Okay. Questions? You will be quizzed over everything that we've learned on Friday. Yes, you will get a periodic table for Friday's quiz. If there are no other questions, then you have the rest of the period to finish your practice.
May I borrow the board?
Like, how do you find out what the last 3
I
Are you going to bring it back?
So
Sure. Yes, of course.
I
Uh,
understood
Bye.